Hi guys, so today we are going to be starting 8.4 inverse of trig functions. I would suggest if you have your 8.3 unit circle, I would print or pull that out or just print another one on Google or something just so it's kind of easy to reference to. So we are going to be talking about inverse, and with inverse, what this is going to help us find is angle measurements. So we know how to use hopefully radians and degrees. So if I have sine of an angle measurement equaling, so for example, we were working with, let's just say sine 1/2. Okay, so my angle measurement is pi over 6, so that means sine is 1/2. Well, if I was given sine theta equals 1/2, we need to be able to know that that is pi over 6, or 30 degrees. The symbol that we're going to use is this -1 as an exponent. So I have sine inverse of A is going to equal that theta measurement. So we're going to be using this. Use inverse to find angle measurements. Okay, so let's look at example 1a. So I have the sine inverse of root 2 over 2, and it wants us to find all possible values. So this all is actually going to be key. Okay, so I want to pull out my unit circle. And we are going to look for where sine is root 2 over 2. Okay, so if I look here, it goes cosine, sine. So I have sine being 1/2. So that doesn't work, okay? So we're going to the next one. Sine is root 2 over 2. That does work. So I know that the angle measurement is going to be pi over 4. So I have pi over 4. Okay. Since it does say all possible values though, if I look here, if I were to add 2 pi to this, I would have 9 pi over 4. Those are coterminal angles, okay, vocab from last time. And that is still having that sine value be root 2 over 2. If I were to add another 2 pi, I would still have that sine value being root 2 over 2. Add another 2 pi, sine value is still root 2 over 2. So now no matter how many times I'm adding 2 pi, my sine value is always going to be root 2 over 2. So how we're going to indicate this is by adding 2 pi, and then we're going to say n. Okay? And n is going to represent, we'll say rotations around the unit circle. Okay, so that is how many times I'm going around. So if I say pi over 4 plus 2 pi times 2, I'm going around 2 times. So then I also, if you want to look on there, if I keep going around, I still have another value where root 2 over 2 is the sine value. Okay, so that's a no, no. Here I do have another positive root 2 over 2. So I could also have it being 3 pi over 4. So we're going to put 3 pi over 4. Okay. Once again, I can go around the unit circle, and I'm adding 2 pi every time to get those coterminal angles. So we're going to indicate that by saying plus 2 pi n. Okay. All right, so let's look at B now. So I have tangent being 1. Okay, so the ones that I wrote are my tangents. So tangent is root 3 over 3. That does not work. This one has a tangent of 1. So once again, we are going to have that angle measurement being pi over 4. Okay. we are going to add that 2 pi n because I can go multiple times around that circle. Okay, so then go to the next one. It is a -1, so that is not going to count. Next one, I do have a tangent being +1. So my other radiance measurement or angle measurement is going to be 5 pi over 4. So I'm going to have 5 pi over 4, and then we're going to add that plus 2 pi n again. Okay, I want you guys to try both C and D. Real quick, we're going to change this one to a -√3 over 2. Okay, so try those out. When you finish, and you can push play and see if you guys got the same answer as I did. All right, so cosine inverse of 1/2. If I am looking on here, we have a +1/2. So that's a no, no. Yes, we do have a cosine being a +1/2. So that means my radiance is going to be pi over 3. We're going to add that 2 pi n. Back to my unit circle. Cosines are negative here. Cosines are negative. Cosines are positive. So I do have this +1/2 at 5 pi over 3. We're going to add that 2 pi n. Okay, so just a reminder, the reason we are adding 2 pi n is because it says all possible values. All right, last one, I have -√3 over 2 for cosine. Okay, so cosine is positive here, so that won't do. I do have negative cosines here, so -√3 over 2 is going to be a 5 pi over 6. We add that 2 pi n. And then I have -√3 over 2 here, so it's going to be a 7 pi over 6. And then we're going to be adding that 2 pi n. Okay? Hopefully that's nothing too crazy for you yet. All right, next thing I do want to talk about, let me move this just a tad, is the trig functions. Okay. We are going to start having some restrictions now. So for sine, it is going to be negative pi over 2 to a positive pi over 2. So if you want to think about it, on my unit circle, okay, I want to get all values of sine that I can get. So I have sine is positive here. So I have a +1/2. Well, if I look here, I have a +1/2. So those are kind of the same values. So that's why we're restricting it from the positive pi over 2. Okay. If you go down here, I have negative signs. So those are different values. I have a positive and I have a negative. So we have different values, and that is why we're restricting it to pi over 2 to negative pi over 2. Okay, so we're going to say that is our restriction for that one. For cosine, it's from 0 to pi. Okay, so same idea. If I'm looking at cosines, I have all the positive values, and then I have all the negative values. So from 0 to pi, we have all cosine values. Tangent is going to be similar to sine. Okay, so we're going to have these. Because if you look, tangents, I have the positives, and I have the negatives here. Okay. Key thing though with tangent is you cannot include pi over 2 and then this negative pi over 2. The reason that is the tangent over here, remember, is sine over cosine, so that'd be 1 divided by 0. So this is undefined. So same idea, this one would be undefined. So that is why we cannot include those when we're talking about tangent. Okay. I'll actually write that down just to kind of keep that a little bit more in your brain. So don't include negative pi over 2 and pi over 2 because they are undefined. Okay. We're gonna do one more box to fill out and then we'll stop for the day. So on that next page, we have the inverse trig functions now. Okay, so for inverse sine, once again, we're gonna have that sine with the exponent of -1, and then whatever that value is. My domain is going to be from -1 to 1. Because if you think about the unit circle, if you remember, we're going from 1 to -1, 1 to -1. So my domain is always going to be 1 to -1. Okay, my range, so we're once again going to do that -π/2 to π/2. And if you're talking in degrees, that is going to be -90 degrees to a +90 degrees. And then we have our cosine. So then I'm going to have cosine inverse of the angle measurement. I have the domain being the same. Okay, and then I have from 0 to theta to pi. So theta is between 0 and pi. Then if you're talking about degrees, it's going to be from 0 degrees to 180 degrees. Then for my tangent, this one's going to be a little bit different. We will eventually be graphing this stuff, and this will make sense once we get to there. Okay, so I'm having from -infinity to infinity. My range is going to be from that π/2. Oops, we are not including this time. To π/2, which is -90 to 90. Okay, and we'll talk more in depth with example 2 tomorrow.